They are not joining.
Maybe they will want to just benefit on the recording. So with the hands-on, usually I think the first week we spent the first week also doing a lot of the general concepts of AWS. So the hands-on is just to back up all those things we've learned about S3, EC2, and some of the other funny stuff we heard or learned about. Yeah. So right now we are just going to jump back into the AWS AI practitioner curriculum again. But still, I'll make sure that those Saturday classes, you guys are free to join them. They are not really meant for you, but I always share the link with you guys because they are still, I think they are quite beginner friendly. And when you get inside the exam room and they are asking certain questions, you wouldn't be thinking too far because basically you've had a feel of how to implement some of the services. Yeah. It's just a plus. It's just a plus. Okay. Any questions for me so far with regards to the exam prep and everything?
Is
I
it
think we don't have
all?
any question.
So, who said? Sorry, Shadrack, I just joined.
Sorry.
Go ahead.
Sorry, I just joined. Talk to me, please. I beg you.
Yeah, so all that I said in brief is that the Saturday sessions are going to be more of hands-on. And those sessions are not limited to the AI practitioner course we are learning. They are just general AWS services and how to implement some of their solutions, right? But it is still beginner friendly. So when you see me posting the link for Saturday sessions, you may join the session and you may not be hearing anything AI. But as I said, it's just general AWS. And it is quite helpful to also have some general idea of most of the services and how they are implemented. Even if you just sit in a class and watch them do what they are doing, and you don't even do any of the things, at least your mind will be open to certain things, which may end up being helpful in the exam hall. Yeah. Okay.
Thank you
I'm
very
asking if
much.
it is always at 2 p.m.
Which of them? The Saturday sessions.
Yes.
I think I've moved that one to 7:30 p.m. So your Saturday sessions are at 7:30 p.m.
Okay, so that's the one you're making reference to. I thought the one
Yeah.
you last
Not
week.
the one I think that one was an impromptu call, right? I think that one was an impromptu. But I'm referring to the I remember. Yeah, I wanted to give you guys some bonus class, but it seems most of you were busy. But the fixed one is the 7:30 p.m. one. Yeah, that's what I'm referring to.
Oh, okay.
And that will be handled mainly by Engineer George. Because around that time I'll be half dead, so tired. Okay, yeah. Okay, so without wasting time, I think we are all okay now. We can move on.
Sure.
Okay, good. So, I think some of us have an experience with a little machine learning or AI? Maybe. I'm just guessing. But if you don't, no worries. That's why we have week 2, this second module. Okay, so over here, we want to look at, I wish I could cancel this word right now, master, because we are not necessarily going to master the core concepts, but we will get exposure to the core concepts, yeah. And know what is required for 20% of the exam is centered on this week 2. So it should let you know how much weight week 2 is carrying. And we are just doing 8 weeks, right? I've broken the whole course into 8 weeks. Funny enough, I'm calling them weeks, but you can see our bear witness that a week can even span more than 2 physical weeks, right? So don't be deceived by this word week you see here. I planned initially that I'll use 2 months or 8 weeks to finish the course. But I realized that, see, if I want majority of you to pass, I might just give you some free bonus weeks and courses in line. So don't be worried. We are more than 4 weeks into the program, or more than 3 weeks, but we are still saying we are at week 2. Don't let that worry you. It's whether I am the one who's rather bearing the cost, right? Because if the course is longer, you guys are not paying more. You are still paying the same amount, but I'm teaching you more. Okay, let's roll. So we want to understand artificial intelligence, and it is very simple to understand. What is artificial intelligence? We are saying it's a branch of computer science, okay, that enables machines to mimic human intelligence, right? So basically, I was talking to someone that we, at different point in time, look at intelligence from different angles. In basic school, if you are able to memorize what the teacher gives to you, and the next day a question is asked, and you just pour out what they've given out the previous day, you are called to be an intelligent child, right? So there's a certain level that intelligence is all about memorization. But when you get to higher levels, you realize that it's not just about the things you've memorized, like at the university level, master's level, doctorate level. It's not just about memorizing things and then standing up in front of everyone to recite everything you've memorized and they clap for you that you are a doctor, you have a PhD. It wouldn't work that way, right? So at certain levels, intelligence have different ways of being measured, or the metrics used to measure intelligence. Sometimes we need you to critically think, to solve novel problems that no one has ever solved before, bring new concepts about, and what have you. And it is what we are trying to make computers become like. So there's a certain point in time whereby we were happy when the computers were able to now solve certain questions, common questions, or you ask the computer a question and it's able to answer you. Basically because it has a database somewhere it's just referencing to. It's like a chew and pour sort of intelligence. But I got to a point in time whereby we were no longer satisfied with computers just doing chew and pour. But we wanted them to be creative, or we are looking forward to the day that computers will now be able to create new concepts, new theories, solve novel problems, make breakthrough discoveries for us. And that one, we are not yet there. So we are somewhere in between the chew and pour stage and the advanced stage I just described, right? And usually you hear people calling the advanced stage that we are looking forward to getting maybe in the next 10 years, 20 years, 50 years, nobody knows. Some say it is very far into the future. Some say it is very close to us. But if you ask me out personally, I'll tell you it's very far. We call that one AGI, Artificial General Intelligence. That's when the computer has become like a human being. And to be so difficult to distinguish the two. So on this course, we are just limiting this AI, artificial intelligence, to the computer being able to mimic human intelligence, right? Not the lower one of chew and pour, but being able to now learn from the data that we give to it, then look at the patterns in the data, then based on those patterns, it's able to make predictions which are in line with the patterns it has learned, not deviating from those patterns. Okay. So solving, learning, reasoning, perception, and language understanding. Okay. So we will want to look at the key distinction. So AI is just a broad concept, right? Whereby we talk about the computers or machines becoming smart. Then we have this part under AI called machine learning. So AI is very, very broad. And we also have machine learning under artificial intelligence. And here we look at just feeding the AI with data, ask it to learn from the data like a student who has been given a textbook to learn. Then later on, we would ask the AI questions. Then we expect that from what it has seen from the data or its learning, it should be able to make certain decisions or give us certain predictions. And in this case, it's not like we telling the computer, okay, so first of all, let me show you what I mean in practical terms, because some of these things can become so abstract. So at first, when we are creating a chatbot, right? Imagine I'm creating a chatbot for students who are learning specifically photosynthesis. I will tell the computer if definition, right? Let's say this is pseudocode, it's not real code. So if it sees that the child is asking something about definition, okay, maybe I'll tell the computer to respond with photosynthesis is the blah, 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 blah. If examples, or maybe if let's say, if raw materials, don't want to be typing these things. If raw materials, then what are the raw materials, right? We have carbon dioxide and water, right? If I can remember. And H2O. So over here, I'm explicitly programming the chatbot with all the possible scenarios that it can ever be asked. Now, if the person is asked any, or if the chatbot is asked any question that it doesn't know, I'll just tell it to respond, not, it be answer not available, right? Answer not available. So this is what we call explicitly programming the computer. So when somebody starts chatting with this computer and the person asks a question like, so the human being will now ask the question, define photosynthesis. Then it goes into the, we call these things rules. It now goes into these rules and it will definitely land on this particular rule, right? Whereby it will just spit out the definition for us. Photosynthesis is there, blah, 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 blah. Now, this is what we used to do to deceive people that their computers are intelligent, right? We can have about 3,000 rules or 50, let's say 1 million rules. And you'll be like, hey, this computer, when I ask it any question, it's able to answer the question for me. It's actually not thinking at all. It's just going to the rule sets and picking the one that is closer to what the question you ask and giving you the answer back. So this is not really, it may look like you are chatting with an intelligent system, but behind the scene is just somebody say if else statements. Okay. Now away from this, that's where we now arrived at the point of time whereby we wanted to do machine learning. We really want to teach the AI such that we don't have to write so many of these rules, 1,000 or 1,000,000 of these rules, but the AI brain is trained on different scenarios. So let's do as the AI brain is fed with the data, it learns from the data, it understands different scenarios all from the data. Then now when you place this AI inside the chatbot and someone asks these AI questions, the AI can respond to the person intelligently, right? Without the rule-based system I spoke about or described, without any if-else statements. And then it feels like you're even chatting with a human being. This is what machine learning does. We no longer need to explicitly state rules, but we just have to train the AI. Any questions before I continue? So we don't explicitly program it by giving it rules, if else stuff, but rather we feed it with data and allow it to learn from the data so that it can answer questions based on what it has learned, not based on rules we have hard-coded inside or behind the scene. Any questions? Okay, no questions. Let's roll because we don't have much time. Now, for this particular exam, okay, there are types of artificial intelligence, or they group artificial intelligence to these three main types, right? And usually the focus is more on the narrow AI applications. So we have the narrow AI, general AI, and then the super AI. Now, super AI is something that, as I mentioned, we are trying to work, or we are working towards that point, whereby we have the artificial general intelligence, artificial super intelligence, what have you. We can call it different names. But over here, we are nowhere here. So the exam doesn't focus on this one at all. What we are going to focus more on is the narrow, or what we call the weak AI. Now, this AI is designed to perform very, very specific tasks, right? It doesn't have general capabilities. So sometimes you may be chatting with an AI bot on the internet. It looks like it is good in math, it is good in the humanities, it's good in what else? Physics and what have you. Sometimes behind the scene, what is going on? It is just an aggregation or somebody will say concatenation of different specialized models, right? Which are working together to make it appear that there is this single intelligence that you are communicating with. So usually what we work on now is just to specialize AI or these artificial intelligence models or these computer brains in specific areas. And then later on, we can combine many of them to behave as a unified body, right? And then it can solve many problems for people. Currently, we have ChatGPT, which is even able to take text, it's able to take pictures, it's even able to receive your audio and then analyze it. That's what we call multimodal system. It takes different types of data inputs. But behind the scene, there are models that are specialized for text, models specialized for audio, models specialized for pictures, which are ingesting those kind of data and then giving you feedback. It's not just one unified model sitting somewhere doing that. Okay. So we are saying that we want to excel at one thing, but not generalize to other domains. And these are some of the examples of these specialized models on AWS. The first one is Amazon Recognition, right? This AI is specialized in identifying objects in images and helping you to recognize what is going on in an image, right? We also have Amazon Alexa, just like Siri and what have you. It's also a voice assistant. Then we also have a recommendation engine used by Netflix, right? Also specialized in, after you've watched one movie, it tells you, hey, would you like to watch this next movie? Or you can also use recommendation systems in, let's say, if some of you have shopped on Amazon before, let's say Jumia, you buy one product, then before you realize they are showing you another product. And they may even tell you those who bought this product also bought this product. And that's how recommendation engines basically work. They give recommendations and it drives sales a lot for companies, right? So if you later in the future you become a specialist in AI engineering, you can build some of these products for companies and they'll be willing to pay you if you're able to prove to them that, hey, I can build a recommendation engine, we can triple your sales. Most of them will be able and willing to pay you any amount for you to integrate this into their web app or whatever. Okay. They also have AI specialized in spam, right? Detecting spam emails that are just making noise in your inbox, trying to distract you. And then they can detect those spam emails and then filter them for you. Okay. Then also have AI that is specialized in playing chess. Somebody can just program an AI, which is very good at playing chess. Most AIs may not be able to do that, but he can train this specific AI on a lot of chess games and scenarios, right? So the AI learns all from so many scenarios. Then later on, when you want to challenge that AI to a game, it will beat you hands down. And it happened some time ago, I think some many years ago, when this AI evolution was taking place. An AI beat a chess grandmaster hands down. And then at that level too, we say that the computer has become very sophisticated or intelligent. Okay. Now, the next one is the general AI, right? And this is the one that we assume is able to take on tasks that human beings should be able to also take on. And not just take them on, but perform very well with them. And currently, we can try to put ChatGPT in this category. But some people may also debate that, hey, ChatGPT is just a collection of what? Many narrow AIs. It's not just one thing doing everything. Okay. So, as I said, some people say current status, it doesn't exist. Others may also debate that what then is ChatGPT doing? ChatGPT is also able to take on human tasks and then perform them very well. But these two, as I said, generally, most AI engineers and data scientists will tell you that we are not here. We are rather here. And when we combine many of these now AIs, we make them appear as if they are now we now have general AI or super AI. But under the hood, we all know we are just using what? Narrow AI. Okay, any questions at this point before we continue? Okay, let's continue. So AI applications and domains. So usually when a client comes to an AI engineer and then begins to narrate their problem to you, right? I have a farm and I've noticed that some thieves break into my farm at certain times of the day. I wish my security cameras will not just be passive cameras, but they can actually detect when a stranger enters my farm and then sends me a text message or sends me an alert or an email. So once the person begins to talk, then within your mind, you are thinking, is the problem a computer vision problem? Is the problem a natural language processing problem? Is the problem a speech recognition problem? Recommendation engine system problem, autonomous system, predictive analysis, etc., etc. So that's how AI engineers basically think, right? And what I just described, what do you think that problem will fall under among the few I'm showing on the screen? Just let me know in the chat. Which of these do you think that problem will fall under? Anyone? Just guess.
Is it computer vision program, like object detection program or something?
Awesome, awesome, awesome. So that's a typical computer vision problem, right? So that the cameras will now send their feed to an AI model. So you have the camera somewhere trying to, or picking the feed, right? The security camera on the farm, picking the feed. Then as the camera is picking the feed, we connect this camera to what? An AI model. But this AI model is a computer vision what? Model, right? Which may be able to break down the video into frames and then do object detection for each frame of the video. So as soon as it notices something interesting or funny, then it may flag that particular thing in the video, right? So this can be a whole business, right? Because of late, each time I'm driving through the town or even through neighborhoods, I see a lot of people with security cameras now. But most of these cameras, I know they are just passive cameras. So maybe some of you may be interested in taking this as a project, right? Transforming passive cameras to what? Cameras that are actually doing active monitoring. They are able to flag and blue alarm, sound alarm when there's something wrong. Okay. So, rightly said, there's a computer vision problem. And AWS, as I said, has services like Amazon Recognition, which are already made, right? You don't have to go and even train this model. This model is already made. And that's one of the amazing things about the cloud services. You just pick them and then integrate them into your application. So the application which is already doing video streaming, right? You can find a way of just feeding the video streaming data directly to Amazon Recognition and then configure it to be able to do this object detection for you. Then once the model flags something, it can now send another service in AWS, right? Can be triggered to also send a simple notification to you. So there's a service in AWS called Simple Notification Service. It can send you an email. So this is how sometimes an AI engineer may be expected to think. Combine this service with this service, with this service, with this service to bring about a solution. So see, if you're interested in this project, I am here, free consultation. You can start researching. Wherever you get to, I'll step in and help you for free. Is that good news? I'll just help you with my expertise for free. I hope that's good news. So maybe by the end of this course, some of you should be doing amazing things. Don't just be a passive learner. Sometimes I just talk very slowly and quietly, and it looks like we are not doing anything. But I'll be there and some students to just ping me that, hey, what they said in the class, I've started working on it. Please help me. Then I jump on the call, I coach the person to finish their projects at no cost. But if the course ends and you call me, that one I'll charge you. So make sure that you start thinking whilst we are doing this course. Okay, next one.
We want
So
to
we
find out,
have, yeah, Susan, go ahead.
with what you just described, do we have some in the system already integrating the motion sensors into the passive cameras?
I think it should be in existence. Yeah, some should be in existence. I think I can just do a Google search. Some should be in existence.
Okay.
Some people have their own proprietary software they can use for this.
Okay.
But as I said, maybe if you want to a simple solution without doing so much work or so much training yourself, you can just do the simple integration. The person will just be billed. Of course, AWS will definitely bill, right, Susan? They just bill you some dollars at the end of the month. But it will be something you can easily do within some few days for the client. Yeah.
Hello, Shadrack.
Okay, Michael.
Hello, Shadrack.
Okay, it's Emmanuel. Emmanuel, go ahead.
Yeah, so I know with the normal CCTV cameras, when you go into the DVR, there's a
Mm-hmm.
portion where you can enable or disable motion sensors. And
Mm-hmm.
very often when you enable it, any human being anytime you appear in there, it starts disturbing.
Mm-hmm.
So I don't know if this one will be intelligent enough to be designed in a way that maybe at odd hours, you can
Mm-hmm.
program it at odd hours. When it detects any motion, then you can raise the alarm.
Okay. So what I'm
Thank
even
you.
talking about, yeah, good. What we were even discussing right now is not even about motion detection, it's about computer vision. So this is about object detection within a video or let's say a picture. So those motion detection, I know there are motion sensors, some of them use infrared and echolocation and what have you, right? So when you cross the line or when the there's the sensors detect motion within their range, a specified range, then they can sound, some of them will just make noise. Sometimes it's not even a human being, a dog, a bird, anything passing and hitting the line of sight area, it will just blow the alarm, right? Yeah. So what we want to do is that we want to help such a system whereby with computer vision, we can actually recognize the person. So some of these models, we can configure them in such a way that, let's say if you are even train them yourself, I can get pictures of people wearing masks, people wearing funny dresses, right? Like dark space shades and dark, what do you call it, hoodies and what have you. Then those kind of people dress in that funny way, I'll flag them as thieves, or I'll teach the model that this person is likely like a threat. Do you get it? So that it's not just anything at all that is passing in the line of sight, no. But this time around, it's looking for a kind of image, right? So when you see somebody in a dark hoodie or wearing a mask or carrying a weapon, then to flag that kind of object, and then we can trigger our alarm system. So in that case, it will reduce the noise in the whole system by just flagging a dog, a housefly, anything passing by. I hope it makes sense.
Yes, sir. It does.
Okay.
So if I bring up that project now, is it possible? Can we?
Oh yeah, we can do it if there's money involved.
Okay. All right. Thank you.
Okay, let's continue. So we have object detection, detecting whether the thing's an apple, is a meat pie, is a chicken, is a dog, is a human being. Object detection. Image classification, maybe blueberries, blackberries, smooth berries. You can classify them, right? Put them into different classes. Facial recognition, very powerful. When we want to detect whether the person is a family member or not a family member by looking at the face of the person. So this is able to recognize people by looking at their face. That's what we call facial recognition. So for instance, we can train the model with face of people in the household. So when any other person comes to the house, is not a member, alarm system will be triggered. OCR, I think most of us have used OCR, right? You can just use your camera to take a picture of maybe your text, maybe a textbook, and then before you realize, OCR will go through the picture you've taken, and then all the text in it, it will copy it for you, so that you don't have to type the text yourself. It has just generated the text from the image. It has identified the characters inside the picture. So if you take a picture of your, let's say, a textbook, OCR can look at that picture, and then all the notes in that picture, it will retrieve the notes for you. And I use this a lot sometimes when I'm in a hurry, right? I don't want to type. Just take pictures. I remember some of my people were solving some exam questions, and they were lazy to, you see, they were using AI. Let me tell you what they were doing. They were using AI to solve the exam questions. And they were delaying, right? Because they had to type the question for the AI. Then the AI will now give them the answer. And the questions can be very long. So one of them just came up with the idea, see, use your phone to take a picture of the question. So when you take a picture of the question with, I think, Google Lens, yeah. Google Lens can have a way of doing OCR for you automatically. Then it will detect all the text in the picture you have taken. Then you can click on copy. So you copy it and they pasted it in a WhatsApp chat. And they copied it from WhatsApp chat and give it to the AI. And the AI solved the question for you. So that's an example of an OCR, optical character recognition. Okay, so all of these things are in Amazon Recognition Service. And AWS says, just come, plug and play this. And any of these things you want to do, our service can do it for you. You don't need to be a data scientist to do this. Okay, natural language processing. Now, when you want to do deep analysis of text, someone has put something in the chat. What is in the chat? Let me see. Gloria says great news. Okay. Then means the way people are saying great news, I must hurry up and finish this course before people start worrying me. Okay. So natural language processing. So over here, we want to take text. I want to analyze the text and then be able to generate insight into the text. And I've been doing a lot of this for the past 2 to 3 years now. So basically, some companies, let me not go and bring something that I'm not supposed to bring up. Some of these things are confidential. Let me take another example. Let me see. Let's say this call, okay, this very call that we are in. I can allow the AI to generate what we call a transcript, right? So the transcript will be generated. Transcript basically is everything that we are seeing, everything I see, everything you see. We do what we call a voice to text, right? A voice to text. So we convert all our voice or all our speech. Let me just say speech to text. We convert our speech to text. Then the text we have, it is just all that we've said, which is now in the form of text. Now, at the end of this particular call or meeting, some of you may want to know, like, what this guy say in, like in a nutshell, like summary. So we can give the whole transcript to an AI, and the AI can generate a summary from the transcript. So imagine you have this application you created, right? So that you can just, anyone can record a meeting with their phone. When you finish recording a meeting with your phone, the person should just maybe send the recording to the AI app you have created or upload the recording there. Then the AI app will take its time, generate a summary of the entire meeting, generate all the key points of the meeting, generate the action items, generate what again? The recommendations. It will generate so many insights about the meeting for you. And then it will send it to all the people on the email list, like all the stakeholders who need to know about what went on in the meeting. Even those who could not even attend the meeting, they can have these outputs. And then they benefit from the entire meeting, right? So that could be your AI, the AI app that you may create to help people get much more from the meeting that they have. But sometimes you have a meeting, somebody has to write the meeting minutes. It's a whole lot of work. You have to employ somebody to write meeting minutes. And then the meeting minutes, some of them don't even make sense, right? So you can develop a solution like that. So a solution like that is actually natural language processing. You want to process, you want an AI that can understand human language and then delve deep into the language to generate insights for us to use, useful insights. So over here, we have a couple of things that we can do. Sentiment analysis. Sentiment just means like, I want a simple word to use. Probably what's the best word? The grammarians here should help me. So sentiment, maybe how you feel about something, right? Basically how you feel about something. Whether you feel good about it, whether you feel bad about it, whether you are angered or annoyed by the thing. So we can have an AI which can look at the speech and conversation and then generate sentiment or do what we call sentiment analysis on every sentence. You can do it at a sentence level. You can do it at a phrase level. At the end of the day, it can tell you those who were angry in the meeting, those who were happy in the meeting, those who were sad in the meeting, those who were indifferent, neutral. It can generate all those stuff for you, right? So imagine you integrate this into a customer service application, whereby people who are calling your customer service, you generate a transcript, you pass the transcript data, that is the text to the AI model, and the AI model now goes there into the transcript to check whether your customer service personnel was actually responding to the person in a good mood, right? Whether he responded well, whether he was able to answer all the questions in a professional way, whether they were professional or unprofessional, whether they were fighting with the clients, whether the way they responded will even bring clients back to you. So you can automate this system using the NLP service of AWS called Amazon Comprehend. Then at the end of the day, if you have a very big company, you receive about thousands of customer service calls every day, then the one who is the head of that department, you can make their work easier in terms of monitoring all the customer service personnel. At the end of the day, the AI does all of this insights generation, sends a report to the HR or whoever is in charge, management, the senior customer service representative or whoever. He has a report on all the customer service people, those who are performing well, those who should be appraised, those who should be fired, or maybe not fired, but maybe reproached or corrected, right? And you are making life easier. You are empowering a certain part of the business, right? So that's what we do when we are thinking of natural language processing, integrating AI to deal with human conversations, human text, and then generating insights for us that can be useful. Okay, any questions on this? And trust me, natural language processing is a very big thing now. So you hear that somebody is called a data scientist. Some of us are just specialized in just one of the things like natural language processing. So for me, this is actually my specialty. I do computer vision, but I don't call it my specialty, right? I have friends who are also specialists in computer vision. But my main area is NLP, natural language processing. Okay, next one, speech recognition, right? Amazon Polly is there. The rest of them, I'll just skim through them a lot of time. So Amazon Polly can just imagine Polly the parrot, right? Parrots like talking a lot. So when you want to convert, do speech to text, text to speech, voice commands, and what have you, you are going to make use of Amazon Polly. And usually it is used in text to speech applications, right? You have a text, you want to convert it into speech. You have speech, you want to convert it to text. So think of personal assistants. You record your voice, but the AI models or brains, they don't really understand the voice. So what actually happens behind the scene is that when you are speaking and you are recording yourself, that audio file is sent to a speech to text model. Now, this speech to text will change all your speech to text, normal text. Then the text can now be fed to the AI model. Now, the AI model will analyze the text and then give also a text output or text analysis or text response. Then we can now use Amazon Poly to now change the AI text to speech. So at the end of the day, to sound like you are speaking to the AI and the AI is also speaking back to you. But behind the scene, we have a speech to text model and a text to speech. So usually these are the things, these two models are used a lot when you want a chatbot that can take your voice or hear you talk and also respond with a human voice. Okay, so that's for Amazon Poly. Then recommendation systems. Basically, the questions I've seen here, they don't ask too many things, right? And I've already spoken about what these systems do. They look at your previous, let's say, buying history or viewing history. If it's a movie like system like Netflix, look at the kind of movies you've been watching, and then based on that, you can recommend other movies which maybe fall in the same genre or something like that. And also, if it's about shopping online, you can also have a recommendation system there. You can tell, hey, if you've bought this item, if you bought a toothbrush, check out this amazing toothpaste, which can make your teeth very white. The person may not have thought of buying toothpaste, but because of the next content that came up, it was like, well, I think let me just add a toothpaste. So this system, for instance, trust me, it is a money-making system for lots of companies, right? So it's like you guys taking my AWS AI Practitioner course. Once you're done, I'll just tell you, why don't you take the associate course also? And I know most of you are willing to take it, right? Who doesn't want to go higher and get some higher contracts? Awesome. Any questions for me? I can keep on going. Okay, no questions. Let's go. So autonomous systems that don't need a lot of push buttons before they act. They can understand their environment. They can take actions independently, right? Without being remote controlled or steered. And we are looking at self-driving cars, drones, robotics, and what have you. Right now, most of these systems want to go autonomous. Autonomous is actually the future, right? You sit in a car, tell them, take me to the supermarket to drive you there. And AWS has a wonderful service, still in development, but very powerful, called AWS RoboMaker. So if you are interested in autonomous systems, you can go and look at that one more. I don't know how soon these things will get to Africa, but outside the country is very prolific. Okay, next one, predictive analysis, right? You can build forecast models on AWS using SageMaker. You can also go to Amazon Bedrock and do that. But they also have a service that they have prepared, which they have made very powerful for forecasting, right? Example is demand forecasting, enabling you to know when customers will buy what kind of product, so I can beef up your stock before people come and you tell them we are out of stock. Fraud detection, predicting fraud scenarios even before they happen, so that your cyber team will always be empowered to take action or be prepared to take action before the worst happens. Risk assessment tool can also use this powerful AI to make predictions, right? And can enable you to reduce your risk profile. Okay. Are we good to go? Type good in the chat, and I know we are good to go. Now we are about to now delve into the machine learning fundamentals. Okay, some people are typing good. So we have about some 15 to 20 more minutes. I'll be done shortly. Don't worry. So I'm giving you just 1 minute. Grab a cup of water and let's delve into this. 1 minute break. Okay, I'm back. So what we'll be doing is that, see, now it sounds a little too much theoretical, right? But over the weekend, we have one full walkthrough, if not even two. I'll prepare two for you, one for classification, one for regression. So this will be hands-on, right? So that every one of you can build a machine learning model or brain. I'll teach you how to do that in just a single notebook. We'll do that. Okay. So let me quickly run over this, the theory aspect, then let's prepare for the weekend for the practicals. Okay. So basically, what are we going to look at now? So we are saying, I've already explained machine learning, right, as a subset of artificial intelligence. So right now, almost everything we see, we are saying AI. But most of the hard work goes on with the people who do actually do what we call machine learning. They are the ones who build most of these brains, right, that we use. And we call those kind of guys machine learning engineers. Now, there are two guys that I want you to be mindful about. And let me put their names here. So you know the ones who are really the hard guys who are building the models. So we also have the machine learning engineers. Then we also have the AI engineers. These two people, it looks like they are doing almost the same thing, but they are doing different things. So as I said, these people are the ones who usually build the AI brains of the models, right? But the AI engineers, they don't really build the models. Let me say they don't build the models, they don't build the brains. But they are also very good in software development. Right now, most of the AI engineers we have now are software developers who have learned some of the AI principles, like what we are being taught in this course, right? And AI fundamentals. And because they already know how to program, right? The AI models that are available on Amazon, OpenAI, and what have you, they know how to program and connect their softwares to these AI models to something we call APIs. So right now, the AI models that are available on Amazon and OpenAI and what have you, they have APIs, application programming interfaces, right? And with these APIs, when you have a software, okay, you can basically write a program that enables your software to connect to this API. So the API, behind the API is the AI model already built, this already made model. Either it's made by ChatGPT owners, that's OpenAI, it's made by Microsoft Azure, made by AWS, Amazon. The model is here. All you have to do is just be able to write a good script that can communicate to this API. So if you want to get a summary, let's say you're doing NLP, you have the transcript, you can send the transcript data through an API call to the OpenAI API to a summarization model. It does a summary for you and just sends the summary back. And then, so maybe the client puts their long text here and they click summarize. When they click summarize, at the back door or in the back end, you are sending this transcript to what? OpenAI API. Let's say they are charging you $1 for this call you are making, $1. But in your app, you are charging customers $5 to get a summary from their text. So the $1 you get, you send the text the customer put in your app to OpenAI API. The response comes back, the summary comes back. Then you show the client the summary. Did you build this model? You didn't build the model. Did you create this powerful OpenAI ChatGPT model? No. All you did was to write a script that is able to communicate with the powerful model that is built by someone and then get a response and then show that response in your app. So this is what AI engineers basically do. They learn how to interact with these amazing models that are being built by companies every day. They try to understand their documentation and then so that they can know how to communicate with the models through their APIs. And then they make API calls to do whatever task they want to do. So they want to do object detection, computer vision, whatever. You just find a computer vision model on OpenAI. make API calls to that model, get a response, and then serve that response. Does it make sense? So that's the role of AI engineers. But the machine learning engineers, they will be working day in, day out to train these models to develop the brain itself, to get us this brain itself. Then the AI engineers now take the glory. Okay, any questions? I hope it's very clear.
Can you
So
please
you
go
can easily
over
become an
the
AI
AI?
engineer, right? Just make sure that you go and refresh your software skills. If you're already a software engineer, just take most of these things I'm telling you seriously. And then before you realize, you can change your title from software engineer to AI engineer. Okay. Any questions before I move? Okay. So I've already spoken about the rule system that we have moved away from to now training computers through machine learning so that they can answer questions without writing too many rules to be checked. Okay, now there are, let's say, 4 types of machine learning, right? And among the 4 types, what we'll be looking at on Saturday, maybe I may do 3 with you so that I can cover supervise and then some of the unsupervised. Reinforcement learning, maybe not this Saturday, maybe another time. Semi-supervised, not in this course, but we can look at that later. So supervised learning, let me talk about it briefly. With supervised learning, what we will do on Saturday, this is what we will do. We'll find data, okay? This is like the way human beings also learn in basic school. We'll give the data to the AI model, right? And then we'll require it to learn from the data. So we have what we call the training data. Then we also have what we call the test data. There's another one we call validation data, but I don't want to talk about that one now. But we can talk about it later. Maybe Saturday, but not today. Let's just focus on these 2, training data and then test data. So imagine these 2 as in training data is like your textbook, right? What you are given in school to learn. And the test data is the exam questions. And definitely the exam questions should be based on the textbook, right? If your teacher gives you an exam that doesn't have any relationship with the textbook, then that teacher should be a wicked teacher. So what we assume basically is that the test data is data that has not been seen by the model, as we don't expect you to have seen the exam questions, right? We expect that you have learned something around those questions, but those specific questions like maybe describe or state 2 importance of photosynthesis. We don't necessarily expect that you know that that's what is coming, but we expect that during your learning or the training phase, you'd have seen the definition of photosynthesis. So we try to help the model, right? So usually we have a data set, and then we divide this data set into 2 parts. They can be 3, but as I said, let's focus on 2 for today. So we'll call the larger part the training data, and we call the smaller part the testing data. So we allow the model to learn, okay, from the training data. Usually this one can be 70% of the entire data set. Sometimes it can be 80%, right? If it's 70%, it means that the test data will be 30%. If it's 80%, it means that the test data will be 20%. So we will do what we call a train test split. We'll see that one in action on Saturday. So we just get the data set splitted using what we call train test split into the training set and a test set. Then we will allow the AI model to see everything inside the train set. It will see everything. But what is inside this train set? The train set And a test set to is it is in the form of questions and answers. So the answers are what we usually call labels, right? We call them labels. So just imagine it to be like this. What is photosynthesis? Then the answer will be like photosynthesis, blah, 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 blah. What is this? Then the answer is blah, 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 blah. Just imagine it or picture it that way, but it's not really like that. So at the end of the day, after you do the training, they will come and ask you the question again, maybe in a different form. Maybe this time we'll not ask you what is photosynthesis, but we may ask you, what is the name given to the process, okay, or the chemical reaction which takes place in plants, which leads to the production of, let's say, oxygen. We can twist the question and frame it in that way. Then this will be one of the test questions, and we expect that the model should know the answer. So when we are even testing the model, we don't show the model we know the labels or the answers, or what we call the marking scheme, we know it. But we only give the model the questions here. Then when it finished answering the questions, we will now take the answers that we do not show it, that we know, or the marking scheme. And then every single answer the model gives, we either give it correct or wrong. If the number of correct are many, we say that the model is a good model. If the number of wrongs are more than the correct, we say the model is a bad model. So basically, this is what data scientists do. So I can create a model. Maybe I want to create a model that will determine whether a conversation will lead to marriage or not lead to marriage. So what do you think I'll need? What kind of data do you think I need? Who can tell me? I want to create an AI model which just looks at the first maybe 1 hour conversation between a man and woman who go on a blind date, right? Then I'll predict whether the conversation, from the conversation, I'll predict whether whether they told them will get married or not get married. What kind of data do you think I'll need? Any idea? Guys, we have just 10 minutes, so let's do this. Let's be snappy. If you have an idea, tell me. If you don't have an idea, you just tell me I don't have an idea, and I'll tell you. So this is what machine learning engineers basically do, and I'm trying to make it very simple so we get it. Any idea I should tell you? If I should tell you, just type tell. Just type tell in the chat, and I'll tell you.
I believe the data
The
you
funny
need
data I'll be collecting.
a conversation between
or
between
are they asleep? I hope you guys are not
boyfriend and
asleep. And you left me here. Let me see the chat. Team, are we here? Okay. Somebody was typing. The data regarding marriage. Okay. Who else? Any other ideas?
So you gather boyfriend.
So basically, what I'll be doing,
girlfriend.
hey, Isa, you were here or you are chopping some TZ because the way you took long for you to respond. Isa, you didn't invite me. Okay. Okay, so basically what the kind of data we'll be collecting, okay, will look like probably the conversation, right? As you guys are saying, conversation. Then remember the label. The labels, we need the labels. So the conversation may be, I love blah, 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 blah. Then maybe this one, the label will be maybe married. So I need historical data. So that's the kind of data I need of conversations. Then maybe this conversation led to what? A not married case. So I'll collect a lot of these conversations, and then what happened at the end of the day? Because remember, we are training the AI model. It needs to see examples of things that led to marriage, examples of conversations that did not lead to marriage, so that it can learn from the pattern. So basically, this is what. So when a machine learning engineer wants to create a model, an AI model that can be used for something, this is our thought process. Get data that is in line with what we are trying to work on, and preferably if you are doing supervised learning. So that's what I'm talking about right now. Then we will need what? Labels. The labels is like the outcome of whatever you're looking for. So that when the AI looks at this whole conversation and it learns that these people got married, it looks at this whole conversation and learns that these people did not get married. So it will be learning from, let's say, 1 million conversations, those that ended up in marriage and those that didn't end up in marriage. At the end of the day, if I just give this AI model maybe another conversation, maybe that starts with love is blind, blah, 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 blah. Then the AI will now tell me, AI will now, from all the training that it did previously, it now tell me that, oh, these people, they will get married. Am I making sense?
Yeah.
If I'm making sense, type yes in the chats. This is what we'll be doing on Saturday. Maybe I'll bring this same scenario and then we'll build a model for this.
Yeah.
Hey, you people really like love. When I said I'll build this same scenario, people are answering yes, yes, fast, fast, fast. Okay, let us continue. Okay, let's continue. So we have these scenarios and then let's continue. Let's continue. So right now we know what the data looks like and what a label looks like. So for supervised learning, what we basically do is that we will use labeled data. Label means that we are telling the computer about the outcome of whatever we are training it on. Okay. Now for unsupervised learning is the other way around. There will be no column called label or let's say marriage status. There will be no column like that. So for a case of unsupervised learning, we may rather be asking the computer, okay, to just group these conversations into maybe 3 categories for us. So this time I will just be feeding the AI with conversations, right? At the end of the day, the AI will now create the label by itself. So what we are looking for, the AI is the label. So the AI may put the conversations into maybe 2 categories, 2 main categories. Then surprisingly, you, the AI engineer, you will go into the conversations and realize that, from the patterns of these 2 major groups, the ones that it put in group A, it looks like all of those cases are like cases about people who got married. And those in group B, they look like people who are likely not to get married. So the AI, some way, somehow, was able to study the patterns in all the conversations and put the conversations into 2 groups. Maybe it did not necessarily label the 2 groups married or not married, but definitely it has found some patterns or certain things in common with certain conversations and it has grouped them into 2 main groups. So that's what we call unsupervised learning. We do not tell it about the labels per se, but the AI itself went into the data and has tried to understand the patterns and group the people. Any questions? So that's what we'll be doing with the unsupervised learning. So supervised, we'll give it data together with the label. Unsupervised, we will not give it any labels, but we'll still expect it to put the conversations or items into groups. Then we can analyze the groupings later on. Okay, some few more minutes and we're out of here. Now, reinforcement learning. What is it about? So over here, we're saying it's learning through trial and error, right? What do you mean by trial and error? So the model, first of all, understands what we call an environment, right? And tries to learn from its mistakes it makes in certain decisions, right? So those mistakes, it gets penalized or punished for the mistakes it makes. So because of the punishment is being given for the mistake it's making, it tries not to make mistakes. Then we try not to be too wicked, right? When it makes a good choice, we give it a reward. So when we are training AI in this kind of system, whereby we let it allow it to learn from its environment, make decisions, punish it, or reward it. Then we are doing reinforcement learning. So over a period of time, the AI learns how not to make mistakes. And this part is being used in some autonomous, or let me say most autonomous systems. The only downside to this thing that it can take so many training, for the AI to arrive at a point whereby it has really learned well. Some way, somehow, I think human beings learning how to walk go through this same process, right? You must learn how to balance yourself on your feet, else you fall down. So you can look at the falling down as the punishment that you receive first. When you fall down, you may hurt yourself a little. Then you try to stand up on your feet again. So through that process, you learn that, hey, I must stand on my feet flat. I will not just stand on one toe. Because standing on one toe always makes me fall down and I hurt myself. So you go to that punishment and reward learning. And then at the point in time, you master the right way to place your feet on the ground. And basically, that is reinforcement learning in simple words. Okay. Now we have the last one, semi-supervised, right? Where we use a combination of labeled and unlabeled data. Or when we have limited labeled data. So basically, you can just show it a few examples, and based on those few examples, it carries on the rest of the process of labeling the entire data set for you. As I said, this may not be a concentration point for us, but know that we'll talk about it later on when we get to Amazon SageMaker, right? Okay, so the most important thing is that you know that these examples can be produced, okay, using AWS services. We can just go to SageMaker. Instead of building our own models, we can do autonomous learning and choose certain configurations that allows us to do supervised learning, right? We can also do unsupervised learning in AWS. Okay, we can also do reinforcement learning. This one's actually free. So on Saturday, I may show you how to just sign up for this. This is free. This is a free service. There are even competitions you can take part in, right? And even win certain rewards. AWS Deep Racer. You can even read ahead of the class. Then SageMaker Ground Truth. Later on in the course, we'll also look at that. Okay, any questions? So the rest of the material, I'll just send the notes for you to go to these notes. I've already explained them, right? But classification we will do on Saturday, regression we will do. Then I'll add probably clustering. And if there's time, we will add either anomaly detection or dimensionality reduction. Because these two, a lot of questions feature on them. Okay, before we log off, any questions? Then next week, the plan will be to do some deep learning theory, then do the practicals also. Any questions before I log off? If we are good, just type good. And I'll send you these notes right after the class. Are we good? Okay, good to hear. Good to know. So team, that's all for today. Make sure when you get the notes, you just spend some time and go through them and prepare for Saturday's hands-on session. Have a lovely evening. Take care. Bye-bye.